So I'm going to attach their cells. So we're not actually using cells here. This is just blue food dye. And then there's these little glass beads. They're just little white beads that they are bigger. They're about white cell sized. Right. So these are about 15 micron. So they're going to be retained, and then we're going to wash the blue off. So what we're hoping to go from is this cloudy blue to just cloudy clear, and the blue is going to be in that supernatant bag. Okay. That's what we're going to see. Okay. So that first part of it is going to be the prime.
Prime. Yep. So that happens. It moves pretty quick then.
Yeah.
Okay, and it's priming.
So it's first going to prime. It's going to push fluid to our cells here, so you can see the bubbles getting pushed out there.
Yep.
And then once it detects that fluid actually makes it there, then it'll stop.
And how's it detecting that?
These are all weight scales.
Oh, through the weight scales.
Yep.
Okay.
And then it's going to do the other bags the same way. So now it's pushing fluid into this bag, and when it sees that there's fluid there, it's going to stop.
And it just does that by weight?
Yep.
Okay. And then it's also priming though over here.
Priming the spinner.
So now it's doing the spinner there.
So this is going through.
Sorry.
So it comes down this tube.
Yep.
Goes first through this top guy.
Yep, that's what's pumping.
Yep. And then it goes into our spinner.
And you can see it coming out of that bottom line.
Yep.
So it's all priming that bottom line out.
And then that goes to.
Priming is not something that everybody does that who does this process, but they don't do it automatically like this. Is that sort of?
That's kind of a unique thing for us. That's something that has to happen. If there were air in here, funny things happen to the cells. So we need to get all the air out. It's a requirement, a self-imposed requirement on our part.
Okay. So priming is not something everybody does. That's something you guys do. That's the unique thing.
Correct.
Currently, they're not even using an automated machine. I guess they use like a centrifuge.
Okay.
Or they'll do it in bags in the centrifuge.
Bags.
Or they'll do it in little conical vials and have to dump the top solution, spin down all the cells so they drop to the bottom, then dump it off, and then add more solution, shake it up, and then go put it in the centrifuge again.
Got it. Okay.
Okay. And you want to start the process? So I'll go through this bag.
Yep, so it's going to start pulling from there and feed it into the spinner.
So that's going now through this middle
When you see watch
guy.
the spinner, you see the color sort of enter.
Made that a little more concentrated, but what you'll notice here is the opacity of the solution here. It's pretty clear, and down here it's opaque, right? So we're concentrating those beads that are just floating there, and it's clear coming out of that supernatant line. That's all.
So over here, the blue is coming off.
Okay, yeah. So it's coming out the bottom of the spinner.
Yep.
Through that. Is that an air detector?
That's a clamp.
That's a clamp.
Clamp. Okay. And then over to this guy. And so that's filling up your weight. Well, I call it waste, but
Supernatant.
yep, supernatant.
Yeah.
Yep. Okay.
So it's going to go until it knows this bag is empty, either through an air detection or through the fact that the weight scale stops changing.
Completely empty every time, or is that something that's set up by the operator?
Completely empty every time.
Okay.
Now, it may not always be on a scale. If you're starting with a tank of cells, so you just pull out of that until you read air. That's why I say either if the scale's in use, it'll look at the scale, and when that's empty, if it's pulling from a tank, something that's not on a scale, it'll look for air.
Oh, gotcha. Okay. What do the tanks look like? Not that it matters for us, but
They'd be bioreactor. I mean, they're big cylindrical things like that, or it might be a bag, a big bag that's just sitting on a tilt scale.
okay.
So it processed all the cells. It noticed that they were empty. It does a little rinsing mechanism. You can still see that there's some white in there, so it tries to rinse that out.
Oh, okay.
Always to make sure that we have all the cells. The cells are the important part.
For most people.
For most people.
So it fills it up with a little saline fluid, and then will it then run that through again as well?
So it'll just transfer that fluid and those cells into our in-process. So it's gonna, after the little rinse, it's just going to make sure that everything is either in that supernatant bag or in the in-process bag.
Okay.
And once this clears out, I'll take this bag off.
All right. And then I'll pause tape, and then we'll go into log 2, right?
So it's going to automatically go.
Oh, it will. Okay. Let me know when that happens, and I'll just
Sure.
break it up into...
There it goes. It should detect now. So that's our concentrated cells in that rear bag.
So now it's
And what's the makeup of this?
That is concentrated cells. So 90% of the fluid
Yep.
is taken off, and that's what's the cells and 10% of the remaining fluid.
Gotcha. Okay.
So right now it's bringing that volume back up to the original volume.
Gotcha.
So if we were to process that again without any of that dilution, we do one more tenth reduction and are left with very little fluid. So
But you said if you're trying to deal with that total, you can lose a lot of the cells in the tubing and stuff like that.
So just that spinner itself houses about 7 milliliters of fluid. So you can imagine if you try to concentrate with that, using that down to 3 milliliters, it doesn't really work. So there's a minimum volume we have to have over here for us to actually be able to effectively process them.
I'm going to split